Today's topic of discussion is lost in cosmos. Lost in the cosmos. Okay, so here I am going to talk about information paradox. Noise is coming from outside. Please ignore that noise. Information paradox. Okay, so in the study of black holes, if you study black holes, then you will see this term is being used, information paradox. According to physics, information should be preserved. It should be conserved. It's a conserved quantity, information. So, loss of information, it is a paradox. So, that thing will be discussed here in this video. Okay, so here these are the points which will be discussed. First point is classical physics and GR. GR stands for general relativity. Classical physics, according to classical physics and general relativity, black holes have mass as well as angular momentum, and many of the black holes may have charge also, means electric charge. Okay. Kerr-Newman black holes. This is the special category of black holes. From the solution of general relativity, these two scientists, okay, Kerr and Newman, they have found this type of black holes which are called charged black holes, means these black holes may have charge, okay, electric charge. Anyway, here we are not going to talk about those charged black holes. In general, we are going to talk about information paradox here in this video. Okay, so before that, we have to discuss all these points. So, classical physics, according to classical physics, black holes have these characteristics: mass, angular momentum, and charges. Charges, this is optional. Okay, many black holes have charges, and many black holes are there which do not have any electric charge. Next comes QM and information preservation. QM means quantum mechanics and information preservation. According to the theory of quantum physics or quantum mechanics, there will find that during a physical process, whatever information is there about the particles, that is not lost. After reaching to the final state, just by using the final state, the information about the final state, we can easily get the information about initial state. Means information is preserved during inside a quantum system or during any physical process for anything. Okay, information is conserved, it is preserved, it cannot be, it is not lost. Okay, so that is the second point. That was the second point. And next comes Hawking radiation and black hole evaporation. You know, black hole evaporates. Yes, according to Hawking. Okay, there is a faint radiation which is called Hawking radiation, which can take place at any temperature. And this radiation, this comes out from the black holes. Okay, means it is able to cross the event horizon, the boundary of the event horizon. And this way black holes evaporate. Both the mass and the energy are lost. And eventually, they are, one day, maybe it is after billions of years, there will be a complete evaporation of the black holes. So that was the point number 3, third point. Number 4 is paradox emerges. Yes, now paradox emerges. If the black hole completely evaporates, then what about the information which was contained in the black holes? Whenever matter falls into a black hole, it is lost in the universe. This is the opinion of many scientists. This is lost in the universe. But according to conservation of information principle, that information is conserved inside the black hole. But due to Hawking radiation, eventually the black hole will evaporate. So after the complete evaporation, what about the information which was contained inside the black holes? So this way information paradox comes into existence. Okay. And next comes resolution attempts. Yes, scientists are trying, they have already made several attempts to analyze about the information paradox. So there are theories such as string theory and holographic theory. In string, the scientists who are working on the field of, in the field of string theory and holographic principle, they are talking about non-local. They are using this term, non-local. This term is being used by the physicists working in the field of string theory and holographic principle. Means some way information is conserved, but it is being conserved in a non-local way. Okay, so that way they are trying to interpret about the conservation of information by using the concepts of string theory and a holographic principle. So few scientists are there who are saying that during Hawking radiation, okay, the information which was conceived inside the black holes, the information are going or moving away from the black holes with the Hawking radiation. Okay. Again, few scientists are there who are talking about there is a need for change in the theory of quantum mechanics as well as general relativity. Means existing theories are there, you know that thing. Okay, but there is a requirement of modification of those theories to interpret the effect of this paradox, that is information paradox. Okay, and last point was I have written here ongoing research. Yes, this is very interesting. That means many physicists are there who are working on in this area. Okay, this is a broad area of research. Black holes is no doubt. It is a broad area of research, and the subtopic, the topic is black holes, and the subtopic is the information paradox. Okay. So many scientists all over the world are there and working in this field. So this was all about the topic lost in the cosmos. Here again the word lost was used about the information, not about you and me. Okay, lost in the cosmos. Okay, so this was all about today's discussion. Okay, and if you like this video, please press the like button as well as you subscribe to my channel. Okay. Anyway, this is the end of this video. Thank you. Thank you for watching this video.